Welcome grade 6. I hope so that you all are doing great. Today we are going to cover the rest of the topics of chapter number 7, solutions and suspensions. Take out your pencils, rough copies. I want all of you to note down the important points during this session. Alright grade 6. So in the previous lectures we discussed about solutions, supersaturated, saturated solutions, concentrated and dilute solutions, and how water is a universal solvent. So now move on to the page number 71 and we are going to discuss the topic other solutions. There are different types of solutions. For example, air. Air is actually a solution of gases. I have already told you before that it's not always like liquid into liquid. Solution, solute and solvent can be gases, or it can be liquid, or it can be solid. So air is actually a solution of gases. It contains nitrogen, oxygen, carbon dioxide and other gases. Similarly, fizzy drinks are also a solution which consists of a gas, that is carbon dioxide, solids, that is sugar, and flavoring which is mixed in a water. So what's happening here? Gas, solids and water, three things are actually making a solution, that is fizzy drinks. Three most important acids that we are using in the laboratory are hydrochloric acid, nitric acid and sulfuric acid, and all of these three acids are actually the solution of gases in a water. It means here gases and water, they are mixing with each other and forming a solution. Similarly, antifreeze, which is actually used to stop a car engine from freezing, is actually a mixture of two liquids, that is ethylene glycol and water. Now moving on to the alloy. Alloy is actually a solid solution of two or more metals. It means solids, solute and solvent, both are going to be solid. The metals are melted and then they are poured together in the right proportions and they are allowed to cool. For example, brass. Brass is an alloy of copper. Similarly, solder. Solder is an alloy of lead and tin. So there are also some liquid solutions like iodine, which uses ethanol as a solvent instead of water. I have already told you before that water is not always the solvent. We can use different types of liquid as a solvent also. Like in the case of iodine, we are using ethanol as a solvent instead of water. Similarly, turpentine is actually a solvent which is made from petroleum and which is usually used to clean the paints and brushes, etc. Alright class, so here's a little activity. This is a diagram which is showing four different kinds of solutions. A fizzy drink in which gas and solids are dissolved in a water, brass in which zinc is dissolved in a copper, air in which we can see different types of gases are mixed with each other to form a solution, and air freshener liquid is dissolved in air. Now all you have to do is tell me that in these four types of solution, which is a solute and which is a solvent. Like in a fizzy drink, gas and solids are dissolved in water. So what is a solute in this solution and what is a solvent in this? Alright class, on the page number 72 we have a topic of solubility. What is a solubility? In a broad term, solubility is actually the maximum amount of a substance that will dissolve in a given amount of a solvent. What does it mean? That a maximum amount of a solute that can be dissolved in a given amount of a solvent at a specific temperature. So according to your book, the definition is the solubility of a solute is actually the number of grams of a solute that is able to dissolve in 100 gram of water or some other liquid at a particular temperature. It means at a specific temperature, the amount of solute, the number of grams of solute that can be easily dissolved in 100 gram of water is termed as solubility of that solute. Now there are two more terms that are more important discussed in this topic is miscible and immiscible. Miscible liquids are actually those liquids that can easily mix with each other and they do not form separate layers, while immiscible liquids are those liquids that do not mix with each other and they form separate layers. Like for example, we have discussed about oil and water. When we mix oil and water, we can clearly see that there are two different layers, though both of them are liquids, but they are unable to mix with each other properly and they form separate layers. So what will we say? That oil and liquids are immiscible for each other. Alright class, so on page number 72 there is a graph where solubility is placed on y-axis and temperature is placed on x-axis. Remember this, that solids, they dissolve better in hot solvent as compared to the cold one, while gases, they dissolve better in cold water as compared to the hot water. Liquids solubility does not depend upon temperature, they are either miscible or immiscible. So what's happening in this graph is that they are showing the solubility of three substances at different temperatures: the solubility of potassium nitrate, sodium chloride, copper sulfate. They are showing how the solubility of a solid solute particle increases with the temperature. You can see that potassium nitrate and copper sulfate solubility increases with the increase in temperature, but there's a little effect on the solubility of sodium chloride. Alright class, now in the graph you can see that the solubility of sodium chloride is affected little by the temperature. The red line of the sodium chloride is clearly showing that increasing the temperature is not affecting the solubility of sodium chloride as much as it is affecting the solubility of potassium nitrate and copper 2 sulfate. Now take out your pencils. You have to write down these points because these points that I'm going to discuss are not mentioned in your book. We are going to discuss why the solubility of sodium chloride is affected little by temperature. Alright, so the temperature does not affect the dissolution of NaCl, as the heat of hydration, it almost equalizes the heat of dissolution. It means that the solubility of sodium chloride is affected little by temperature because the heat of hydration almost it equalizes the heat of dissolution. Now heat of hydration is actually the amount of heat that is dissipated or absorbed when one molecular ion undergoes the hydration process, and the hydration process is actually the process of combining a substance chemically with a water molecule. Dissolution is actually the process where solid and gases, liquid or solid phase dissolves in a solvent to form a solution. So that's the reason that the solubility of sodium chloride is affected little by the temperature. Although sodium chloride is a solid, its solubility should be affected more by the temperature, but because of the heat of hydration, which almost equalizes the heat of dissolution, the solubility of sodium chloride is affected little by temperature. Solutions and suspension is our next topic. As I've already told you what is a solution suspension, we have also performed an activity based on solution suspension and colloid, so I'm just going to summarize all of the things. Solution is actually a homogeneous mixture in which the particles of solute and solvent are evenly spread out, and we cannot separate the solvent and the solute by the filtration. Light can easily pass through solution, and the particle size of the solution are very less. They are less than 1 nanometer. They are very small. That's why light can easily pass through them, and we are not able to distinguish between the solute and solvent particles. For example, vinegar, fizzy drinks, sugar solutions, etc. Alright class, so the next is suspension. Suspension is actually a mixture of small particles which is suspended or dispersed in a gas or liquid. Suspension is actually a heterogeneous mixture. The basic difference between solution and suspension is that suspension is a heterogeneous mixture, light cannot pass through it, while in solution light can pass through it, and it is a homogeneous mixture. In a suspension, the particles actually settles down or separates. As in the video you have seen that we have used oil and water, so we can easily distinguish between the oil and water. That is, we can easily distinguish between the solute and solvent particles. Suspension has a cloudy appearance, and its these particles are large enough. That's why we are able to see the separate layers of solute and solvent. Calamine lotion, different types of cups, mixtures, medicines, oil and water, all of them are the examples of suspensions. Particles and solubility is our last topic. We all know that matter is made up of tiny particles. When we say that this solute is actually soluble in a solvent and it can dissolve in a solvent to form a solution, what does it mean? It means that those solute particles are small enough that they can easily fix themselves into the spaces that is present between the particles of the liquid. If these solute particles are small enough and they fixes themselves in those spaces, then the solute particles become soluble into the solvent. But if they are large enough, they cannot fix themselves into the space provided between the particles, so the solution becomes insoluble. So now we know that what does this word solubility means and what happens when a solute dissolves in a solvent. If we increase, as I have said, that if solute particles are able to fix themselves into the spaces present between the solvent particles, the solute becomes soluble in a solvent. So if we will increase the space, what happens? Insoluble substance can also become soluble. That's why increasing the temperature of certain solutions helps to dissolve the solute particles, because increasing the temperatures moves the particles away. It increases the spaces between the liquid, between the solvent particles, and more solute, even a big solute particles can easily fix themselves into those provided spaces and becomes soluble. That's why in suspension we can easily distinguish between the solute and solvent particles, because the solute particles are large enough that they cannot fit themselves into the spaces between the liquid particles and they cannot form a homogeneous mixture. Here a diagram is showing how solute dissolves in a solvent to form a solution. When we mix the solute particles into the solvent particles, it breaks into the tiny particles, and these tiny particles then they adjust themselves into the spaces present between the liquid particles, and then it becomes a solution. A very nice and clean diagram showing how to form a solution from solute and solvent particles. Alright class, so today we have completed our chapter number 7, that is solutions and suspension. We have performed an activity in this chapter. We discussed about solutions, suspensions, colloids, solubility, particle sizes, how water is a universal solvent, and different types of solutions. I hope so everything is clear, but even if there is any query you can ask me. Your homework is that you have to thoroughly read the whole chapter, go through the whole chapter, underline the important words, and write answers of question number 1 to 7, which is mentioned on page number 74. I will provide you the answers. Write it down in a neat way. Thank you.